friends, welcome back to my channel SJR Commutative. In this video, we are going to see what are the Boolean laws. So there are a number of Boolean laws. So today we will see what are the laws. Then I will put the values of the variables in the law. Then I will show you how the left hand side of the Boolean law is equal to the RHS, that is right hand side. So that it will become very easy to remember all the laws. Because at a glance, if we see all the Boolean laws, you may feel it is little bit confusing to remember. But actually, if we do the practice by putting the values and if we see how the LHS of the law is equal to the RHS of the law, then it becomes very easier to remember. So let me start with the first law, that is commutative law. So there are two commutative laws, one for the AND operation and another for the OR operation. So first I will consider the first commutative law for the AND operation. We know AND operation is shown by using the dot. So the commutative law for the AND operation says that A into B is equal to B into A. So here I will write that law, A into B is equal to B into A. So here I have not written the dot. So it means by default it is multiplication only. Now see, in this law, how many variables are used? Two variables are used, A and B. So total possible combinations of the values of A and B will be 4. So I will write all those possible combinations here. 0, 0, 0, 1, 1, 0 and 1, 1. So now in this law we will put the values of A and B and then we will check how the LHS of the law is equal to the RHS. So see the first input combination, A is 0, B is also 0 equal to B. B is 0, A is 0. So 0 equal to 0. So this LHS is equal to RHS for the first combination. Now we will consider the second combination where A is 0 and B is 1. So here B is 1 and A is 0. So 0 into 1, 0 and 1 into 0, again it is 0. So again 0 is equal to 0. So LHS is equal to RHS. So this is correct for the second also. Now see the third one. Third is A equal to 1. The value of A is 1. Then B is 0. B is 0 and A is 1. So 1 into 0, 0 and 0 into 1, 0. So 0 equal to 0. So we have proved this law is correct for the input combination 1, 0 also. Now consider the last input combination, that is A is equal to 1 as well as B is equal to 1. So A is 1, B is also 1. Here B is 1 and A is also 1. So 1 into 1, 1 equal to 1 into 1, 1. So it doesn't matter in which sequence we are going to take the multiplication. Here A into B is there equal to, here B is the first variable, A is the second variable. So A into B is equal to B into A. So here I have written the Boolean law for only two variables. This is correct for n number of variables, or in the same way we can write for the n number of variables. For example, if I consider the three variables A, B and C, then we can write the commutative law like this: A into B into C equal to C into B into A. It doesn't matter in which order we are going to write the input variables, but the result will be same on both the sides. For example, here I can write A into B into C equal to, here I can write B into A into C. So actually here the order is A, B, C, here it is B, A, C. It does not matter the order, result is going to be same for the left hand side as well as for the right hand side. So you can check whether these two are correct or not, but in that case we have to consider the three variables. So total 8 combinations will be there for the values of these variables. Now this is proved. We will move to the next commutative law, that is A plus B equal to B plus. First I will write A plus B equal to B plus A, and here A, B, there are 4 combinations: 0, 0, 0, 1, 1, 0 and 1, 1. So now see the first combination where A is 0, B is 0, here B is 0, here A is 0. So 0 plus 0, 0 equal to 0 plus 0, 0. So both the sides are equal. Now consider the second input combination. A is 0, B is 1. Here put the value of B, it is 1. A is 0. Sorry, here A is 0. So 0 plus 1, 1. 1 plus 0, it is 1. So again, both the sides are equal. Now, see it for the third input combination where A is 1, B is 0. So A is 1, the value of B is 0. B is 0, A is 1. So 1 plus 0 is 1. 0 plus 1 is 1. So 1 equal to 1. In the same way, we can do it for the fourth combination also where A is equal to 1 and B is equal to 1. So 1 plus 1 equal to 1 plus 1. So 1 plus 1, 1 equal to 1 plus 1, 1. So both the sides are again here equal. So in this way we can prove all the Boolean laws by using the all possible combinations of the values. So now we will move to the next associative law. AND operator as well as for the OR operator. So for the AND operator, it is into the bracket A, B, outside the bracket multiply with C equal to A into bracket B into C. So I will consider the first law, that is in bracket A into B, outside the bracket multiply with C equal to A into bracket B into C. Now see, actually here it contains the three variables. So total possible combinations of the values will be 8. But here I will consider only one possibility. So you can do it for the remaining 7 and check whether the LHS is equal to RHS. So consider, suppose the value of A is equal to 1, B is equal to 0 and C is equal to again 1. So I will consider this possibility and we will check LHS is equal to RHS. So A is equal to 1 into B 0 dot. What is value of C? It is 1. Put the value of A 1 in bracket. Put the value of B, it is 0 into C is 1. So 1 into 0 is 0. So 0 into 1 equal to 1 into, what is the result of this bracket? 0 into 1 is 0. So 0 into 1, 0 equal to 1 into 0, 0. So for this possibility, the LHS is equal to RHS. And for remaining 7 possibility also, LHS will be equal to RHS. So you can do it by yourself. And if you are having any doubt, please let me know in the comment box. I will make one more video to prove this expression with the help of the truth table. Now we will see the second associative law for the OR operator. The associative law for the OR operator is A plus B inside bracket, then outside the bracket plus C equal to A plus inside the bracket B plus C. So we will try to prove it with the help of one possibility of the values of the inputs. So I will write this law here. Inside bracket A plus B plus C equal to A plus, now inside the bracket B plus C, and now consider the values of A is equal to 0, B equal to 1 and C equal to also 1. So here I am going to consider only one possibility. You can do it for remaining 7 possibilities also. Now put the values of ABC in the given expression or in the law and check LHS is equal to RHS. A is equal to 0 plus B. What is B? B is 1 plus C. C is 1. A, the value of A is 0 plus B is 1 plus C, it is 1. 0 plus 1, the result of this bracket is 1 plus this one equal to 0 plus, the result of this bracket is 1. So 1 plus 1, 1 and 0 plus 1, 1. So don't say 1 plus 1 is 2. We are not performing the addition of the decimal number system. We are using the binary numbers here and it is performing the logical addition. So actually this plus is nothing but the OR operator. So you know the OR gate takes 2 or more than 2 input, and if at least one of the input is 1, then its output is 1. So here two inputs are given to the OR operator, and that's why both of those two inputs are 1, and so its output is 1. So don't say 1 plus 1 is equal to 2. So here you can see the left hand side result is equal to the right hand side. Now we will see the next law, that is distributive law. The distributive law is A into B plus C equal to A into B plus A into C. So now we will see how to prove it with the help of the values of the A, B and C. I will write this distributive law here. A into B plus C equal to A into B. Write this plus operator here. Then A into C. Consider the values of A 1, B 0 and C 1. So now put the values of A, B, C in the law. A is 1 into B plus C. B is 0 plus C is 1 equal to A into B. A is 1, B is 0. So 1 into 0 plus A is 1, C is 1. So 1 into, what is the result of this bracket? 0 plus 1, 1 equal to 1 into 0, 0. 1 into 1, 1. 1 into 1, 1 equal to 0 plus 1, 1. So left hand side is equal to right hand side. Even in maths also we know, if three numbers are given like this, one number is here and here the addition of two numbers, we are doing the same. So multiply, take the multiplication of first this number and the first number in the bracket plus multiplication of the number which is given outside the bracket with the second number in the bracket. So we are distributing these numbers by using this plus operator here. So this is the distributive law. After that we will see what is the inversion law. The inversion law says when we take the double complement of any variable or any expression, the result will be the original value or original expression. So the inversion law is A double complement is equal to A. So we will prove it with the help of the values of the A. So I will write first here A double complement equal to A. Here I will write the possibilities of the values of the A. A can be either 0 or 1. So first I will consider A is equal to 0. Now I will find the complement of A. So complement of A means the complement of 0 here, because the value of A is 0. It is equal to 1. So complement of 0 is equal to 1. So this is a single complement. What I want its double complement. So I will write here A complement and its double complement equal to. Now see what is the value of A complement here. Here the value of A complement is 1 and this complement, upper complement will remain as it is. So the complement of 1 is equal to 0. Now you can see here A is equal to 0 and A double complement is equal to also 0. That means when we take the double complement of any variable is equal to the original variable. Now this is for the first value of the A, that is A equal to 0. Now we will consider if A is equal to 1. Now consider here A is equal to 1. So I will take its complement. A complement equal to complement of 1 is equal to 0. So I will take double complement equal to. Now here the value of the A complement is 0. This complement will remain as it is, equal to the complement of 0 is equal to 1. Again you can see here both of the values are same. So that's why this A is equal to the double complement. Here to explain the inversion law I have considered only single variable, but this law is correct for number of variables. For example, suppose I am having A into B. We can write this A into B as AB double complement, because as I told you, inversion law says A double complement is equal to A. This is same for the OR operator also. A plus B is equal to A plus B double complement. So this is how we can apply the inversion law whenever you are going to simplify any Boolean expression. Now next we will see what are the AND laws. There are 4 AND laws. We will see how the LHS side of the AND law is equal to the RHS by putting the values of the variables. Consider the first AND law. It is A into A is equal to A. So here I will write A into A is equal to A, and here I will write the two possibilities of the values of A. It can be either 0 or 1. So the first AND law is A into A is equal to A. So I will put the value of A as 0. First consider A is 0. So 0 into 0 is equal to 0. So 0 into 0, 0 equal to 0. So actually A into A is equal to A. Why? Because here the value of A we considered 0. So put the value of A, 0 into 0 equal to 0. So we know 0 into 0 is 0. So at last the result also we are getting the 0. And that's why A into A is equal to A. Now we will consider the value of A as 1. So 1 into 1 is equal to 1. So 1 into 1 is 1 equal to 1. So whatever value of A we are going to put, that is the final result of this expression. So this is the AND law, A into A is equal to A. So now we will see the next AND law, that is A into A bar is equal to 0. So here I will write A into A bar is equal to 0. So now first consider the value of A is 0. So I will put A as 0. A bar. What is A bar? A is 0. So A bar will be 1 equal to 0. So 0 into 1, 0. So 0 equal to 0. This is correct. Now consider the next. Now I will consider only the left hand part of this expression. A into A bar. Now put the value of A as 1. So A bar will be 0 equal to 0. So we are getting the 0. So whatever may be the value of A, either 0 or 1. So A dot A bar equal to 0. Next, A into 0 is equal to 0. So here you can see A into 0 is equal to 0. Why the result of this expression is 0? Because it doesn't matter what is the value of the A. Here one value is 0. So whenever we are going to take the multiplication of any numbers with 0, then the result is always going to be 0 only. And the last AND law is A into 1 is equal to A. Why this is so? I will write it there. I will consider the values of A and we will prove how A into 1 is equal to A. So A into 1 is equal to A. So we will consider only the left hand side. Put the value of A as 0 into 1 is equal to 0. So here I am putting the value of A as 0 and the result is also 0. That means the result of this expression is A. Now consider the next value of A is equal to 1. So 1 into 1 equal to 1. So here you can see I have put value of A as 0. I am getting the result 0. Here I put the value of A as 1. I am getting the result 1. That means what? A into 1 is equal to A. Now the next we will see what are the OR laws and how to prove those by using the variable values. Now consider the first OR law, that is A plus A is equal to A, and the values of A can be either 0 or 1. So here I will consider the LHS, that is A plus A, and now consider first A is equal to 0. So the value of A is equal to 0. So here I will write 0 plus 0 equal to 0. Now you can see here we are getting the value of A as a result. So this A plus A is equal to A. Now put the value of A is equal to 1. So equal to 1 plus 1 is equal to 1. Again we are getting the result as value of a. So a plus a is equal to a. If we put a as 0, then the result is 0. If we put a as 1, the result is 1. Now consider the next OR law, that is a plus a bar. Here only I will make the changes. A plus a bar is equal to 1. So put the value of a equal to 1. So a equal to 1, a bar will be, a equal to 0. So a bar will be 1. So 0 plus 1 is equal to 1. Now next, consider a equal to 1. So put the value of a as 1. So a bar will become 0. So 1 plus 0 is 1. So now here you can see, it doesn't matter I am putting the value of a as 0 or 1. The final result is 1. That's why a plus a bar is equal to 1. Now consider the next law, that is a plus 1 equal to 1. A plus 1 is equal to 1. So put the value of a as 0. 0 plus 1 is equal to 1. So 1 equal to 1. So if I put the value of a equal to 0, then result is 1. Now I put the value of a as 1. This is first case. Now consider the value of a as 1. So 1 plus 1 is equal to 1. So 1 plus 1 or 1 equal to 1. So here I put the value of a as 0. The result is 1. Here I put the value of a as 1. The result is 1. So here it doesn't matter what is the value of a. The final result is 1. That's why a plus 1 is equal to 1. Now consider the last law, that is a plus 0 equal to a. So here I will write a plus 0 equal to a. First consider the value of a is equal to 0 and put in the expression. So 0 plus 0 equal to 0. So here you can see we are putting the value of a as 0 and the result is also 0. Now consider the second case where the value of a is 1. So 1 plus 0 equal to 1. So you can see here I put the value of a as 0. The result is 0. Here the value of a is 1. The result is 1. So here the result depends on the value of the a. So a plus 0 equal to a. So if you understand this video, please like my video, subscribe my channel, as well as don't forget to click on the bell icon also to get the notification of my next uploaded videos. And one more thing, please share it with your friends. And if you want me to make video on any other concept, please let me know in the comment box. Thank you.